Hi, so I'm sure you know I'm a lover of old technology, and one of the technologies I just think is fantastic are Wimshurst machines. Now, normally I make these things out of plastic, actually, the rotating discs, but I came across these. These are display shelves, actually, circular display shelves with a centre in it, and it's an enormous piece of circular glass. So, of course, what are you going to do with something like that? I mean, the first thing that comes to mind, of course, is build a massive Wimshurst machine. I've made a few Wimshurst machines, but never out of glass. You need to put the sectors on, those little metal petal shapes that get stuck onto that glass. Now, there's a lot said about these things, but I follow a guy called Antonio Carlos Queiroz. He's a Brazilian professional electrostatics. And he says that really it's going to be somewhere between kind of 18 and 40, depending on the size of your disc. Pretty popular is 24 to 36. So in order to draw a template to get all this stuff on, you just, great big circle, divide it up by the number of sectors you want. So if it's 24, it's every 15 degrees. If it's 36, it's every 10 degrees. And then draw an inner and outer line of where these sectors are going to go. So if you put your sectors too far here, you'll get leakage across there. If you put them too far here, you get leakage into there. So somewhere in that band is where you're going to want to put them. And you're just making quite random guesses about it. Now, sector sizes, you need to leave a gap between the sectors. Let me show you on my template and we can talk about that a little bit more. So here's my circle. It's the same size as those discs. You can see that I've actually divided it into 24 sectors, so they're 15 degrees apart. And then we've got the petal drawn here and here. That gap between them needs to be, in this size of disc, more than a centimetre. But on average, the average sort of thickness of this should be the average thickness of that kind of thing. You can see mine are a little thicker. Doesn't really matter that much because I'm going for area and I've got enough distance here. Now these corners are rounded and you can calculate that if you want. What I actually did was put a washer on there and draw around the washer as long as the washer hit that edge and hit those there. And that's all I actually did, and the same with the bottom, joined them up. When I'd done that, I created this little card template. Then I went around the whole ring with the template because these are for position only. I also took that card template and put it on my metal foil. Now these foils, that's obviously copper. I like copper. It's a harder wearing metal, though it does oxidise. But the number of options you've got really are copper or this stuff, aluminium. This aluminium tape is what's used for heating ventilation. If you use thicker tape in aluminium, then you're going to need to glue it. This comes pre-glued as a tape. The negative is it does wear out a bit quicker, but obviously the copper is harder metal, so that's going to be longer wearing. So again, the size of the sectors, how they're positioned, really, it doesn't matter that much. It depends what you're going for, high voltage, high current. The metal that you use, again, it's not really that important. Copper, tin, aluminium, whatever you can get stuck on there easily. But once you've done that, you need to cut out a whole bunch of these petal shapes, because that's what we're going to stick on the glass. To attach it, peel back your backing. I line up the bit with the backing paper still on into one of the petals. Hold it down, rub that bit down, and then peel that bit on. There we go. Now you need to give it a rub over with your finger or a spoon, get rid of all those sharp edges and any air bubbles, and then go around the whole disc and stick all the rest. All them down, that's what you get. You see what I mean about the copper? I just think it's lovely, actually. 2 of these discs and we're ready to put them in a frame. So now we've got these things, of course, what we need is a cradle to hold the whole thing together. And I've done the bosses so that you can do a traditional one if you like, but I'm going to go a slightly different way. So we remove those bosses because this is a great big bit of glass. I don't know if that's centered or not. If I try to spin it on that, it may well be out of true. I'm not 100% sure, but I want to go a different way with it because I think that's looking really funky. And my way that I'm thinking about is like they do a hubless wheel. Rather than having a central drive, to put some support around here so that the thing can rest in a cradle and then drive it off the rim. And of course, we've got 2 of them, so we drive one off the rim in one direction and the other off the rim in the other direction. Now, to do that, what I've got is some pulley wheels that I got from the local store. These pulley wheels are 30mm pulley wheels and they do fit rather nicely on there. leaving me a little bit of a gap, which I want anyway. So I'm going to arrange the pulley wheels around the rim. So I need to make a cradle and arrange those pulley wheels. Now the material I'm going to use to make the cradle with, of course, is, ta-da! Builder's board. Now I often mention this and regular viewers will know exactly what this is. But for those who aren't regular viewers and have just tuned in, this stuff is used for roofline in Europe and the UK, and in the USA you're going to need to get something called Sintra board. It's a really cheap, really strong structural material used for roofing, so it's gonna last. Now the wonder of this stuff is it glues with super glue, so the glue joint is stronger than the original material, and I make loads of models with it. I absolutely love it because it's so easy to work with. So we're going to make a cradle for this using this. So that's all there is to the cradle. I mean, it's a couple of bits of that with some bearings in it, skater bearings of course, and then this little pulley section here. And what I love about our world actually is how everything is so precise. I mean, they have to do it that way in order to mass produce, but it still gives you a lot of precision. So these spacers here, they're olives. They're 8mm olives from plumbing section with some 8mm washers to make sure that those pulleys, which were 8mm, all line up. So we've got them lined up, we've got them in some bearings, we can pop that board on there like that, and then this, says he, will ride in there. So I've offset the pulleys, so this pulley and this pulley, sorry, this bottom one and the top one are further that way. These two are further this way, so the two glass discs will actually be separate but resting on their own pulleys. Anyway, let's put that bit together. Okay, so there's the cradle finished and we've slotted the glass in. Now the glass is clearly a bit wobbly, so we've got to do something to stop that wobble, which either means putting something at the top there or something at the side. So we need to build out this frame and then correct that wobble. Okay, so that's the cradle complete. I'm loving it actually. I think it looks really weird and kind of different. Now, the main things we've got to do to it now are add the neutralizers, add the collection combs and the capacitors. So the capacitors are going to stand like here and here. Neutralizers will go here, and then obviously across the central we're going to have the collection combs. But that is the heart of the machine. Now in order to drive it, what we've got is a couple of motors here, and they're just a friction drive using those pulleys with a bit of rubber on them straight against the glass, and so they just press against the glass and rotate those wheels, one in each direction. That's because the positive is connected to the positive on here, but that positive goes to the negative on here and vice versa, so those two motors rotate in a different direction. Let's give it a bit of voltage and we'll see that thing spin up. That's awesome, it really is. So we've used a couple of large bits of glass and we weren't sure where those centres were. So doing it like this with the resting in the cradle, and incidentally in this top is another of those pulley sections to keep everything here from wobbling. This is just made out of waste pipe actually, 36mm waste pipe. But that keeps everything close together and in true without us having to put a central axle in there when we're not really sure of where that centre is. Anyway, I'll continue with this, but there's the heart of the unusual Wimshurst machine. I hope it was of interest and thank you very much for watching.